This is Lois, someone who moves through life on his own terms. His electric wheelchair takes him pretty much anywhere he wants to go. Pretty much anywhere. Lois has muscular dystrophy, a condition that progressively reduces muscle strength and range of motion. That means certain things most of us do without thinking become real obstacles, like pressing a button to open a tram door.
So, ich bin Lois. Meine Hobbys sind so Powerchair-Hockey spielen. Zum Beispiel ist es so wie Unihockey, einfach mit einem Rollstuhl. Cool, was irgendwie so ein Hilfsmittel gemacht wird, wo einem auch so unterstützen. Kann ich selbstständiger mit dem Tram und sonst allgemein mit dem ÖV unterwegs sein.
That was our challenge, building a device that allowed Lois to press the tram buttons on his own. So, how do you build something that gives someone their independence back?
We are Team Lois, and this is how we try to answer that.
Hi, I'm Chiara. I'm a mechanical engineer and I'm the technical lead.
Hi, I'm Karim, electrical engineering student and testing and documentation lead.
I'm Kamil. I study computer science and I'm the challenger liaison. I'm the link between us and Lois.
Hi, I'm Maria, project manager and videographer. I make sure the project moves forward.
From day one, we had one rule: design with Lois, and not just for him. So we started by listening, understanding how he moves, what he can do, and what he actually needs. The one thing he was clear about is that he wanted to be in control. That brought us to our first idea: an extendable armrest attachment. Lois places his arm, it moves sideways and reaches the bottom. We built a prototype, but the bottom was still out of reach. And with muscular dystrophy being a progressive condition, relying on arm strength alone wasn't going to be a long-term solution. So, back at the drawing board, we moved to a second idea: a motorized linear actuator, a device that would extend forward, press the tram button, and come back. No arm strength needed. Lois stays in control. So we went to the trams and measured the exact force and distance the device needed. Then we got to work. We tested different motors, different gears, different designs. We 3D printed, we failed. We printed again. Build, test, evaluate, and repeat. One afternoon in the makerspace, it worked. The rod extended, retracted, extended again. We may have celebrated a little. Here's what we built: a compact 3D printed mechanism mounted to the side of Lois' wheelchair. Inside the casing, a motor turns a set of gears, which move the rod forward and back. This is connected to an Arduino and controlled by Lois when he presses the button. One thing that we kept coming back to is that this had to fit into Lois' life, and not the other way around. It had to be easy to use, quick to attach and remove, and not get in the way of anything he already does. We placed the control right next to his joysticks and added a yellow safety button that brings the rod back immediately if needed. The mounting system consisted of a metal bar screwed to the side rail with a mechanism attached to it with Velcro, secure when it needs to work and easy to remove when it doesn't. With the whole system integrated, the real test was always going to be with Lois. So we went back to the tram. He lined up the device, pressed the trigger, the arm extended, the bottom lit up, and the door opened. At the end of this project, we didn't just hand over a prototype. We handed over a bit of independence, and that felt like enough. One bottom, that's all it takes to get on a tram. For most people, it's automatic. For Lois, it was a barrier, but not anymore.